Hello guys, welcome back to the review videos. So today we are going to discuss sampling distribution. I think this chapter is quite important, sampling distribution. So if you recall what we have been through after the midterm, we have discussed sampling distribution and then we have discussed how to construct a confidence interval. And then last week we talked about hypothesis testing. And also next week we are going to talk about more in depth about hypothesis testing. So if you think about the three parts, especially the confidence interval and hypothesis testing, they are built on the sampling distribution. Like what I said last week in class. So from this chapter, the sampling distribution chapter, what we are studying uh, what we are studying in a sense is the distribution of sample. So it's what we are studying is only about one graph. It's the distribution of the sample, and it's a normal distribution. So that's what we're focusing on. No matter you are talking about confidence interval or hypothesis testing, you will go back to the graph of sampling distribution. I will explain why this is the fact in detail when we talk about confidence interval and hypothesis testing. But right now in this video, I'm gonna focus on sampling distribution. Okay, so back to the sampling distribution. If you remember what Professor said in the first one or two lectures, the reason why we do statistic, why we calculate all these things is because if you take a look at the graph here, it's because we want to know something about the population, right? We want to know something about our population, our study group. So maybe we want to know the mean of the population, right? Oh, I'm sorry. The population mean is the mu. You have to pay attention to these characters. We also want to know the mean of population, right? It's the mean of some certain characteristic like the population height or the wealth of the population. And we also want to know another, like for example, the proportion of the population. For example, how many people has iPhone, how many people has Huawei, right? The proportion of the population. But one of the problem is that sometimes the population would be so big, right? If you want to know how many people has iPhone in China, you cannot do a survey and send it to everyone in China, right? Right, that is too big. So what we can do is we can focusing on a small sample. We can focus on this sample, say 1,000 people, right? We can do a survey for 1,000 people. That's easy. And then based on the result we get from the sample, which is called statistic, right? That's statistic, the name of the course. These are the numbers we get from the sample. And based on this number, we make inference to the number in population, which is parameter. Okay, so this is the procedure why we do statistic. And right, if you take a look at here, like I just said, you have to be careful with those characteristics, characters, because the population parameter, they have their set of character, and the sample statistic, they have their set of character. Right, if you're using mu, then it's mean population. Right, if you're using p hat, then it's mean sample. So be careful with the character here. You might get a little bit confused in the confidence interval chapter or hypothesis testing chapter because a small change of the character, right? And also why character is so important. It is because we only know about sample statistic, right? This is the thing we know. But we don't know about population parameter. We can only guess population parameter. So if you use a population parameter in your formula, it is implying that you are guessing. But if you use sample statistic in your formula, it implies that what you are calculating is concrete based on your sample. Okay. And then it's a point estimator. Point estimator, of course, you can see from here, each one of this in here is a point estimator of population parameter, right? So we come to sampling distribution. So we don't know the population parameter, okay? Then we will study sample statistic. And like what we discussed in the probability and distribution chapter, whenever we want to study some variables, right? These four are variables. Whenever we want to study some variables, we need to draw its distribution. Then the sampling distribution is just the probability distribution of sample statistic. And in this chapter, we particularly focusing on sample mean and sample proportion. And we have learned in class the sampling distribution of sample mean. It's a normal distribution. The sampling distribution of sample mean, it is not essentially a normal distribution. However, these two equations hold for any population. And no matter the distribution of population is normal or not, these two equations hold for any population. If you're wondering how we get the sampling distribution of sample mean, the procedure is that suppose we have 1,000 people. That's our population here. We have a population of 1,000 people. And if we want to get a sampling distribution of our sample mean, the way we do it is that we will draw some random people from the population to form a sample. Suppose we draw 10 people to form a sample. And we will draw as many as we could. And we will draw as many samples as we could from this population. So that is mean we choose 10 from 1,000. And for each sample we get, we will calculate its sample mean. And we will have this many of samples. So we will have this many of sample means. And we draw this sample mean into a graph. Then we will get a normal distribution, something like that. But pay attention, like I just said, not always the sample distribution of sample mean is normal. It is normal only when you draw all the sample you can get and make the sample as large as possible. Then it will become normal distribution. So what I just said is basically about central limit theorem. Central limit theorem. Right? The larger the sample size, the better it will be normal approximation to the sampling distribution. So the larger the sample size you get, the better approximation it will be to a normal distribution. Right? And also the sampling distribution on sample mean is you need to pay attention to the footnote here. Now the subscript here and here. This mu is about the sample mean, and this standard deviation and variance is also about sample mean. Another concept here is about standard error. It's the standard deviation of a point has mattered. So it's just the standard deviation of a sample mean. Why it is called standard error? If you think, you can think it as an arrow, like an interval, right? You could get somewhere. You could get somewhere between this. You can think of it as an interval. So that's why it's called arrow, because you are not 100% sure. That's what we talk about in confidence interval chapter. So that's the sampling distribution of sample mean. The next sampling distribution is sample proportion. Like the example I just mentioned, if you want to know the proportion of people in China who has an iPhone, so you need to get a sample, say 1,000 people sample, and you find out that 400 of them has an iPhone. Then in this sample, the sample proportion is p hat. The proportion of people who has iPhone is 40%. So you make an inference that the proportion of people in China who has iPhone is also 40%. And this is an inference, right? The thing we made here is an inference. It's a guess. It is maybe true or maybe not true. However, we also know that in China, 1.2 billion people, the proportion of people who has iPhone is just fixed. It's a fixed proportion. It's a constant, but we just don't know it yet. We can say it's a p percentage. So if you draw a sample from 1.4 billion, if you draw a sample of 1,000 people from 1.4 billion, and the proportion of people who has iPhone in this 1.4 billion is p%. It means that 1 minus p% people who does not have iPhone. You see what I'm doing here, what I'm implying here? This is very similar to binomial distribution, right? You remember binomial distribution when we learned it in the probability and distribution chapter. Is that for each certain event, there's a yes or no result, either or result. So for each single people in China, the probability of the person has an iPhone is P%. The probability of that person does not have an iPhone is minus P%. So if you draw a sample of 1,000 people, then the probability then the proportion of people who has iPhone is just you choose 1,000 people from 1.4 billion, and in this 1,000 people, there might be X people who has an iPhone, and there might be 1,000 minus X people who does not have iPhone. Oh, I made a small mistake here. You should choose X people from 1,000 people. And how many sample you can get from 1.4 billion people is 1.4 billion. You choose from 1.4 billion and you choose 1,000. So this is the sampling distribution of sample proportion. It's very similar to binomial distribution. And if you remember, binomial distribution is a discrete random variable. It's not a continuous random variable. Therefore, what is a continuous random variable? Normal distribution is a continuous random variable. Binomial distribution is not continuous. It's discrete. So the probability distribution of binomial distribution may look like this, right? Well, this is bad. It is discrete. It's not continuous. However, as the sample become larger and larger, we will have more and more probability, more and more probability. Then you can see it's become normal distribution. So therefore, for the sampling distribution of sample proportion, we only study large samples. This is the constraint of large sample. For the reason that only the sampling distribution of large sample is approximately normal. If it's a small sample, it is not normal, right? Because it is discrete. We cannot approximate it to a normal distribution. So for some sampling distribution of sample proportion, we only study large samples. And remember this criteria to determine whether a sample is large or not. Because in the confidence interval chapter and hypothesis testing chapter, we will also use this criteria to determine whether a sample is large enough. So that's it about sampling distribution. You just remember that it is a distribution of sample. It is a distribution of all the sample you can get from a population. And the larger the sample you get, the better approximation you will get to the normal distribution. That's it about sampling distribution chapter. And the most important formula, I'll use red, is this and this. Oh wait, I'm sorry. I don't want, it's this. So remember these two formula. And the problem professor encountered in class is that she used wrong standard deviation. So because we are studying sampling distribution, always use the standard deviation of sampling distribution. Always use this.